In our previous session, we had discussed about the airplane's axis. Now let us start off with the types of stability. Stability is the ability of an aircraft to correct for its conditions that act on it like turbulence or flight control inputs. For aircraft, there are generally two types of stability, static and dynamic. Most aircrafts are built with stability in mind, but that's not always the case. Some aircrafts, like trainer planes, are built to be very stable. Static stability means initial tendency of the aircraft to return to its equilibrium position when disturbed, and dynamic stability means response of aircraft over a time to disturbance caused. Others, like fighter jets, tend to be very unstable and can even be unflyable without the help of computer-controlled fly-by-wire system. Let us move on to static stability. Static stability is the initial tendency of an aircraft to return to its original position when it's disturbed. There are three kinds of static stability. Consider a marble on a curved surface such as a bowl. Imagine the bowl is upright and the marble is resting inside. The marble is stationary. It is in a state of equilibrium, which means the moment acting on the marble is zero. If the marble is now disturbed, moved to one side as shown in the first figure here, then released, it will roll back towards the bottom of the bowl, that is, towards its original equilibrium position. Such a system is statically stable. Now imagine a bowl which is upside down with the marble at the crest. If the marble is placed precisely at the crest, the moments will be zero and the marble will be in equilibrium. However, if the marble is now disturbed, it will tend to roll down the sideway or away from its equilibrium position. Such a system is statically unstable. Finally, imagine the marble on a flat horizontal surface. Its moments are zero. It is in equilibrium. If the marble is now disturbed to another location, the moments will still be zero and it will still be in equilibrium. Such a system is neutrally stable. Hence, we have stable positive static stability, unstable negative static stability, indifferent or neutral static stability. Positive static stability. An aircraft that has positive static stability tends to return to its original attitude when it's disturbed. Let's say we are flying an aircraft. We hit some turbulence and the nose pitches up. Immediately after that happens, the nose lowers and returns to its original attitude. It's an example of positive static stability. Now, neutral static stability. An aircraft that has neutral static stability tends to stay in its new attitude when it's disturbed. For example, if we hit a turbulence and our nose pitches up 5 degrees and then immediately after that it stays at 5 degree nose up, our aeroplane has neutral static stability. Negative static stability. Finally, an aircraft has negative static stability tends to continue moving away from its original attitude when it's disturbed. For example, if we hit a turbulence and our nose pitches up, then immediately continues pitching up, our aeroplane has negative static stability. For most aircraft, this is a very undesirable thing. Dynamic stability is how an airplane responds over time to a disturbance. It's probably no surprise that there are three kinds of dynamic stability as well. Stable, positive dynamic stability, unstable or negative dynamic stability, indifferent or neutral dynamic stability. Let us look at an example. Consider an airplane flying at an angle of attack alpha e such that its moment about the center of gravity is zero. The airplane is therefore in equilibrium at alpha e. In this situation, it is trimmed and alpha e is called the trim angle of attack. Now assume that the airplane is disturbed to a new angle of attack alpha as shown in the figure. The airplane has been pitched through a displacement alpha minus alpha e. Now let us observe the subsequent pitching motion after the airplane has been disturbed by the gust. We can describe this motion by plotting instantaneous displacement versus time. it changes to a new angle of attack, pitched to new displacement, which results in dynamic stability, which can be classified into aperiodic, damped oscillation, phugoid mode, short period oscillation, and dynamic instability. Dynamic stability. If an airplane is statically stable, it will move back towards its equilibrium position. Is called aperiodic. It may overshoot the equilibrium and after few oscillations with decreasing amplitude to return to equilibrium position is called damped oscillation. Like imagine an aircraft trimmed for level flight and you pull back on the yoke and then let it go. The nose will immediately start pitching down. Depending on how much you pitched up initially, the nose will pitch down slightly nose low and then over time pitch nose up again, but less than your initial control input. Over time, the pitching will stop and it will bring your aircraft back to the original attitude. It is also called as the positive dynamic stability. If an airplane is less damped and its oscillation period is very high and it gains its initial position in a long range, it's called phugoid mode or long period mode. If an airplane is damped and its oscillation period is low and it gets to its initial position in a short period range, it's called short period oscillation. Dynamic instability. If an airplane is statically stable, it may respond to increasing amplitude over a period of time and completely diverge. It is also called as negative dynamic stability. Aircraft with negative dynamic stability have oscillations that get worse over time. The diagram here pretty much sums it up. Over time, the pitch oscillations get more and more amplified. At times, it can also pitch back and forth for a period to time with constant amplitude and oscillation. It is called neutral dynamic stability. Aircraft with neutral dynamic stability have oscillations that never dampen out. As you can see in the diagram below, if you aircraft, it will pitch nose low, then nose high again, and oscillation will continue forever. I hope you would have understood the types of stability. Let us move on to longitudinal static stability in our next session. Thank you.